Most people think ancient water systems were built for farming, or cities, or empires. And yeah, sometimes they were. But the real reason engineers kept perfecting this one clay pot trick was a lot more personal than that. The stickman is caked. Sand in every crease, dried salt pulling at his skin, and the nearest water source is just far enough away to be annoying. Not a crisis, just miserable. So he decides to fix it properly. And what he built ends up being the same thing engineers were building 4,000 years ago on 3 different continents. There's a bamboo pipeline involved, a gravity-fed one. And somewhere in the middle of that pipeline sits a clay pot that isn't storing anything, isn't filtering anything, and isn't doing what you'd probably guess it's doing. We'll get to that. The first thing the stickman tries is the obvious move. Find an elevated water source, cut some bamboo, point it downhill. Gravity does the rest, right? Not really. What comes out the other end is either a warm, weak trickle or a pressure spike that blows the joint apart. Gravity gives you flow. It doesn't give you control. And this is the exact wall that ancient engineers kept hitting. Builders in Southeast Asia running irrigation off mountain streams, Persian engineers extending qanats across desert terrain, Mesoamerican systems pulling water down from highland sources, they all ran into the same problem. Moving water is easy. Moving water at a consistent pressure and a usable temperature is the actual engineering challenge. The physics here is simple once you see it. In a gravity-fed system, what drives the pressure at the outlet is head height. The vertical distance between where the water starts and where it comes out. Double the drop, double the pressure. So the stickman scouts uphill, finds a waterfall with a good vertical run, and starts mapping where the bamboo needs to go. Bamboo is genuinely good pipe material. The hollow interior is smooth, it's lightweight, and it grows fast enough that you're never short of it. You split a section at the node, hollow out the dividers, and you've got a tube. Stack them end to end, lash the joints, and you've got a pipeline. But bamboo joints leak, even well-fitted ones. And a leak isn't just a leak in a closed gravity system, it's a pressure killer. Air gets into the line anywhere along the run, and it breaks the siphon effect. The water column loses its continuity, pressure drops to near zero, and the whole thing just stops pushing. Ancient engineers had a name for this. They called it an airlock, and they designed around it specifically, either with sealed clay joints or with small bleed valves that let trapped air escape without letting the pressure out. So the stickman seals every joint with clay slip, packs it while it's wet, and lets it cure in the sun. The pipeline is roughed in now, running from the waterfall down to camp level. There's real head height behind it. But the water coming straight off that source is cold enough to be uncomfortable. And the pressure is still inconsistent, depending on flow from the falls. The pipe network alone doesn't solve either of those things. That's where the clay pot comes in. Here's what most people guess when they hear clay pot in a water pipeline. They think filter, maybe storage, some kind of sediment trap. That's wrong on all 3 counts. The pot is a thermal regulator and a pressure buffer, and it works through a combination of physics that's almost embarrassingly simple once you understand it. The stickman positions it at a midpoint in the line, below the waterfall source but above the outlet. Water flows in through the inlet pipe, fills the chamber, and exits through an outlet set lower on the opposite wall. That's the basic plumbing. What the pot is actually doing, though, is 3 separate things at once. First, temperature. Water coming straight off a highland waterfall is cold. Not dangerous, just unpleasant, and the stickman has had enough unpleasant. A fired clay pot sitting in open sun absorbs heat through its walls all day. As water moves slowly through the chamber, it picks up just enough warmth from the clay to take the edge off. No fire, no heating element. The sun does it passively, and the clay transfers it. Second, and this is the part that surprised me when I first dug into it, the pot cools itself. Fired clay is slightly porous. A small amount of water seeps through the outer wall and sits on the surface. That surface moisture evaporates, and evaporation pulls heat from whatever it's sitting on. So the outer wall stays cool, the inner wall stays warm relative to the incoming water, and the temperature inside the chamber stabilizes in a narrow range rather than swinging with the outside air. You've seen this principle in a zir pot, the ancient evaporative cooler that's basically 2 nested clay pots with wet sand between them. Same physics, different shape. Third, pressure. This is the one that matters most for making the system actually work. When water flows through a closed pipe at inconsistent pressure, which is what you get from a natural waterfall source, the outlet pulses. Surge drop, surge drop. That's not a shower. That's annoying in a different way. The clay chamber solves this because water fills the pot, and a small air pocket sits at the top. That pocket acts as a cushion. Pressure spikes compress it slightly, and it pushes back, smoothing the flow before it reaches the outlet. The technical term for this is a pneumatic dampener, and you'll find versions of it in plumbing systems right now. The Indus Valley engineers were putting clay expansion chambers into their water networks around 2500 BCE. Persian Qanat builders used them too, not because someone wrote it in a manual, but because the physics kept producing the same answer. So the stickman packs clay slip around the inlet and outlet joints, sets the pot on a flat stone where it'll get full afternoon sun, and runs the outlet pipe down to head height at the camp end. He lets the clay cure for a full day before running water through it. The pipeline is complete. The pot is sealed into the line. The only thing left is finding out whether it actually holds pressure. The stickman opens the flow from the waterfall source and watches the water move into the line. For about 10 seconds it looks perfect. Then the pressure at the outlet drops, steadies, drops again. Not a pulse, more like a slow bleed. Something is wrong inside the pipe run, and the clay pot can only buffer what the line actually delivers to it. He walks the entire length of the bamboo run, joint by joint, and finds it about 2/3 of the way up. One connection where the clay slip didn't pack into the gap fully, left a small channel open to air. It's barely visible, but in a closed pressure system, barely visible is enough. Air got into the column, broke the continuity, and the water upstream stopped pushing with any force. The pressure just sat there going nowhere. This is what ancient engineers built their workarounds for. A bleed valve, in its simplest form, is just a small hole near the top of a high point in the line that lets trapped air escape while water fills in behind it. Once the air is out, you plug it. Some Persian Qanat builders left small inspection ports at every high point in their channels, specifically for this reason. Not to check the water, but to check for air. The fix the stickman makes is simpler. Repack the joint with fresh clay slip, wait for it to set, and run the line again. Second test. Water moves up into the inlet, fills the pot chamber, and comes out the outlet at the camp end in a steady, even stream. Not a trickle. Not a surge. Just consistent flow at real pressure. Enough that when he fits the split bamboo shower head at the outlet and angles it upward, it sprays in an actual arc. He stands under it, and the water hits at somewhere between cool and comfortable. Not cold off the falls anymore. Taken the edge off by the afternoon sun working through the pot walls all day. Exactly the way the physics said it would. That moment is worth sitting with for a second, because what the stickman just built cost him nothing except time and attention. No metal, no fire for the water heating, no pump, no mechanical parts, no material that doesn't grow within 50 meters of where he's standing. The whole system runs on vertical distance in a fired clay chamber, and it will keep running as long as the bamboo holds and the pot doesn't crack. Scale that up, not by a lot. Just imagine a village instead of one person, a clay expansion chamber every 100 meters instead of one in the middle, and a source elevation of 30 meters instead of 10. That's not a thought experiment. That's documented infrastructure from the Indus Valley, from the hill towns of pre-Columbian Mesoamerica, from communities across the ancient Middle East that moved water across terrain that had no natural path for it. The same three-function clay chamber, replicated across cultures that never talked to each other, because the water kept producing the same answer when you asked it the right question. What the stickman figured out, and what those engineers figured out independently, is that water under a sealed path behaves predictably. Give it continuity, give it a pressure chamber, and it does exactly what the physics says it will. The clay pot wasn't the trick. Understanding the system was the trick. The clay pot was just the cheapest way to build the part that made the system work. The stickman didn't invent any of this. He just ran into the same problem that people 4,000 years ago ran into, worked through the same failures, and landed on the same answer, because the answer was always in the physics, and the physics doesn't change. Next time you see a rooftop water tank, a gravity drip irrigation line, a camping shower bag hung from a tree branch, Look at where the outlet sits relative to the source. Look for the pressure chamber, even if it's made of plastic now instead of clay. The logic underneath it is identical to what's running through that bamboo pipeline. Head height drives the pressure. A sealed path maintains it. A buffer smooths it out. Everything else is just materials. What's worth holding onto from this build is that having less to work with didn't produce a simpler solution. It produced a more precise one. Every material choice had to do multiple jobs because there was nothing to spare. The clay pot regulated temperature, buffered pressure, and cooled itself through evaporation. 3 functions, 1 object, 0 moving parts. That's not primitive engineering. That's very good engineering with a tight constraint set. If watching this system come together piece by piece was satisfying, the next build is going to go further. The Stickman's next problem is messier, the terrain is less cooperative, and the solution he lands on shows up in a completely different part of history than you'd expect. Hit subscribe so you don't miss it when it drops.